couple of things are also worth noting. Remember that this rectangle up here is part of the plane which is perpendicular to this line and this line. We can get unit vectors in the direction of this line and this line. We've already seen that. Take their cross product, get a normal vector, so we can tell exactly how this surface is oriented with respect to the XY plane. And that's going to turn out to be very handy when we want to talk about surface area. So we have calculated the normal vector for the general situation. So we know I'm going to write or can easily find, and I wrote OF, make that into a really grotesque R, or can easily find the angle of the plane with the XY plane. Won't go into detail on how we do that, but it's very simple. We have the not going to talk about it right now, but since we've calculated and we know the direction of n with respect to the k vector, and there's an angle between n and k, and that's going to be pretty much the same as the angle between this plane and the XY plane. And the significance of that is that by knowing that angle, we can figure out the factor by which the area of this region is greater than the area of this region. So I can just say that the area of the XY region here is delta x delta y equals 0.1 times 0.05, which is 0.005. It's going to turn out that the area of the roof of this structure is delta x delta y divided by cosine of theta, where theta is that angle between the k vector and the normal vector. And in this case that would be 0.005 over cosine of theta. And if we know the normal vector, cosine of theta is going to be very easy to calculate. Cosine is at most 1, which means that the area up here is at least as great as the area down here. Obviously, if we take a plane and tilt it with respect to another one, the region lying above the original plane or rectangle is going to have going to be greater than the area of the original. So the tangent plane, the behavior of the tangent plane, the angle of the tangent plane has a lot of implications. This implication here would be the surface area connection. Because the area of this region is the contribution corresponding to this delta x by delta y region to the total area of the surface as it lies above the xy plane. And we'll get into that in later chapters, but if you have that insight now, it's going to become easier later on. And just to be complete, theta is the angle between n and the k vector.